All right, 7th graders, we are in section 8.5, continuing with graphing quadratic functions. So in 8.5, we're going to talk about intercept form and how they relate to quadratic functions. So what are we going to learn? Well, you're going to learn a few things. You're going to learn how do you graph functions that are in this form, which is called intercept form. We're going to use intercept form to find the zeros of a function. We're going to use the characteristics to graph and write quadratic functions and something new, cubic functions. So what are we going to do today? Well, intercept form is this. We're going to graph stuff in intercept form. You have already graphed quadratic functions in several forms. Now make sure you know what these forms are. ax squared plus bx plus c is standard form. A and then multiplied by x minus h squared plus k is vertex form. And this is now intercept form. So here's what it means. Let me just kind of show you an easy way of what I am talking about. If I gave you f of x equals, let's say 2x squared, I'm making this up as we go, and plus 14x plus 20. Now, if I said to factor this, you would first factor out a 2, and then you'd factor into binomials, which would be x plus 5 multiplied by x plus 2. This right here, that is standard form, ax squared plus bx plus c. This is intercept form. So intercept form is when you factor out a GCF, and then you have two binomials. And in this case, those binomials are x minus p and x minus q, and a. So here's what's going to happen. You're going to find out what happens with the p and q and how it relates to the graph. So a can't be 0, so this number here can't be 0 because you'd end up with nothing. In this form, the polynomial that defines a function is in factored form, and the x-intercepts can be easily determined. The x-intercepts are going to be using your p and q in your equation. So here's what it states. Before I go over this, let me just kind of tell you what we're doing. If I gave you something like 2 times x plus 1 and x minus 2, all this is stating is that when you graph this now, the 1 and the negative 2, if you actually solve these and got x plus 1 equals 0 and x minus 2 equals 0, and you solve them and got x equals be negative 1 and 2, those are now your x-intercepts. And to find the vertex, you're going to add these together and divide by 2. So your vertex would be, in this case, let's see, 2 minus 1 was 1, half of that. So your vertex is going to be a half. And then you plug that in, and it's going to look something like this. And that is really bad. But you get the idea that these are going to tell you where it crosses the x-axis. So here we go. X minus p and x minus q. The intercepts are p and q. They would be p0 and q0. The axis of symmetry is halfway between that point. So the axis of symmetry is halfway between. And to get halfway between, all you do is add the x values together and divide by 2. The graph opens up. Obviously, if this number here is greater than 0, it opens downward if it's negative, if it's less than 0. Now, to find your vertex, you would actually use this to find the middle, and then you plug that value in to figure out what the y value would be. So here we go. Example 1, I want you to graph the function f of x equals negative times x plus 1 multiplied by x minus 5. Well, the first thing we do is find the intercepts. If you solve these, you would get x equals negative 1 and 5. Therefore, the intercepts are negative 1 and 5, and therefore we would plot negative 1, 0, and 5, 0. So we know this graph crosses the x-axis of those 2 points. Now we need to find the axis of symmetry. The first thing we do is just add these together and divide by 2. So 5 minus 1 is 4, half of that is 2. So the axis of symmetry is just x equals 2. Now to find the vertex, we know 2 is the first value, but now we need to find y. So what we do is we plug in the 2 to our equation. Let's see, 2 plus 1 times 2 minus 5. And so that would be negative 9 times negative, which would be positive 9. So we know the vertex is at 2, 9. And if you graphed it, it looked just like this. 2, 9 is your vertex, that's your maximum. The axis of symmetry is x equals 2. And your two intercepts, your x-intercepts, are negative 1, 0 and 5, 0. Now in example 2, you'll notice this is in standard form. ax squared plus bx plus c. You could find the vertex using negative b divided by 2a and go from there. But instead, we're going to actually factor it. So I'm going to take out a 2. And then I'm going to factor into binomials, which would be x minus 2 multiplied by x plus 2. And we start the same process over again. My x-intercepts. Let's see, this is going to be x equals 2 and negative 2. Therefore, I'm going to plot 2, 0 and negative 2, 0. My axis of symmetry is adding those together and dividing by 2. Well, that's going to just give me 0. So my axis of symmetry is x equals 0. My vertex is going to be 0 something. So all I do is I'm going to take that and find f of 0. Plug it into my equation. F of 0 is just going to be 2 times 0, which is 0 minus 8, which is negative 8. If I graphed all of these, you would get this quadratic function right here. I graphed my intercepts of negative 2 and 2, and my vertex of 0, negative 8. Now, what are the domain and ranges? Well, the domain can be anything here. The domain is all real numbers. Now, the range, well, if you look, my minimum point is at negative 8, a y value of negative 8. So my range would have to be y is greater than or equal to negative 8. We are now going to use intercept form to find zeros of a function. In section 8.2, you learned that a zero of a function is when the x value, is when the y value, f of x, equals 0. You can use the intercept form of a function to find the zeros of a function. And this is actually really easy. Here's the function right here. F of x equals x minus 1 multiplied by x plus 2. To find the zeros, I just set both of them equal to 0, which you can do without showing any work. To solve this, the zeros of the function are negative 2 and 1. In example 4, we're going to do the same thing. We want to find the zeros of the function. So in A, f of x equals negative 2x squared minus 10x minus 12. All we have to do is factor. I'm going to factor out a GCF of negative 2. That gives me x squared plus 5, plus 6. If I factor into binomials, I would get x plus, and that would be 3 and 2. That does give me a middle term of 5x. Therefore, the zeros, if I set each of these equal to 0, my zeros would be negative 3 and negative 2. In the next one, x minus 1 is just going to remain there. And x squared minus 16 would give me x minus 4, x plus 4. That would give me zeros of 1, 4, and negative 4. So 1, 4, and negative 4 would be my answers. Now there's something to make note of here. That example actually is a cubic function. So right here, make note of this. Actually, I'll put it down here. The function in this example is called a cubic function. You can extend the concept of intercept form to cubic functions, and it's cubic because you have 3 different things here. We're going to graph a cubic function in example 7. Using characteristics to graph and write quadratic functions. In example 5, we're going to use the zeros to graph. Once again, you could easily graph this using negative b divided by 2a. But we're going to factor this. So I don't have a GCF. If I factor it into binomials, that would give me x minus 3 times x plus 1. So that would give me the intercepts of 3 and negative 1. I need the vertex. So the vertex would be to add those up and divide by 2. That would be negative 2 divided by 2, which is 1. So I need to plug in the 1. That would give me negative 2 times 2. That would make my vertex 1, negative 4. So if I graph this, I'm just going to make this a really rough graph. So that would give me my intercepts of 3, negative 1, and my vertex at 1, negative 4. My graph would look something like that. In example 6, we want to write a quadratic function in standard form whose graph satisfies these equations. In A, we have a vertex, so therefore I'm going to use vertex form. Vertex form is f of x equals a multiplied by x minus h squared plus k. So that would give me equals, and a, we don't know what a is, but here's the deal. Since I don't know a, this could actually be multiple equations. So we're just going to assume a is 1. We don't know that. So this is just one example of what we could write. Now my vertex, if h, remember this is h, this is k, so h is negative 3. I'm plugging this in so it's going to become minus a negative 3. So it's going to be x plus 3 squared, and then plus 4. But I have to have it in standard form, so I have to actually FOIL this. So x plus 3 squared is going to give me x squared plus 6x plus 9 plus 4, which gives me f of x equals x squared plus 6x plus 13. So let's go to the second one. B passes through negative 9, 0 and negative 2, 0 and negative 4, 20. We don't know the vertex. So we're going to use f of x equals intercepts, which is a multiplied by x minus p and x minus q. Well, I know these are my p and q. So that gives me f of x equals a. And so that would give me x plus 9 and x plus 2, since my p and q are both negative 9 and negative 2. But now I can use the negative 420 to get my a values. So my 20, I'm going to plug in for f of x, equals a, we don't know, and negative 4 plus 9, so negative 4 is my x, negative 4 plus 2, that gives me 20 equals a times 5 times negative 2. 20 equals negative 10a. That gives me a equals negative 2. So a is negative 2. So I plug that in. F to right here. F of x equals negative 2 multiplied by x plus 9 times x plus 2. But that's an intercept form. I need to write it in standard form, so I need to multiply it all out in FOIL. Now I'm just going to go right to the answer. But if you multiply that all out, you would get f of x equals negative 2 x squared minus 22x minus 36. Using characteristics to graph and write cubic functions. Now, a cubic function is when you have an x to the third graph. Now, we have not talked about those. But we can extend our concept of knowing what a quadratic form is in cubic functions to do intercept form of a cubic function. So if you'll notice here, we just add on one more binomial. So our intercepts in this case are p, q, and r, which means the graph is going to cross the x-axis 3 times at points p, q, and r. So we're actually going to graph a cubic function. It's a lot easier than it sounds. So the first thing I'm going to do is just factor. So I'm going to factor out an x to the third minus 4x, and that would give me x squared minus 4. And then that can be factored into the two binomials x minus 2 and x plus 2. That means that this graph is going to cross the x-axis at 0, 2, and negative 2. So if I graph this, zero, 2, and negative 2. So it's going to graph 3 times, or it's going to go through it 3 times. So now we probably need to make a t-table and pick the points between the points. So I'm going to pick, let's see, negative 1 and 1 and plug them in. Negative 1 to the third power is negative 1. Negative 4 times negative 1 is 4, so that's going to be negative 1 plus 4. I'm just going to tell you what they are. If you plug in negative 1, you're going to get 3. If you plug in 1, you're going to get negative 3. So if I graph those, negative 1, 3, negative 1, I'm sorry, 1, negative 3, your graph is going to look something like this. Now that's a bad example, but it looks something similar to that. It's going to cross the x-axis 3 times. So now, given the graph, I want you to write a function. Well, our function is written in this form, x minus p, x minus q, and x minus r. Now my intercepts are 0, 2, and 5. So 0, which I can write like that, 2, and 5. But what do I still need? I need to find a. So I'm going to plug the 12 and the 3 in. So this is my equation. I just have to find the a. So 12 is going to be y. A I need to find. This is going to be 3 minus 0 times 3 minus 2 times 3 minus 5. That gives me 12 equals a multiplied by 3 multiplied by 1 multiplied by negative 2. That gives me negative 6a equals 12, so a equals negative 2. So I plug the negative 2 back in right there, and my equation would be f of x equals negative 2, and then x minus 0 is just x, so negative 2x times x minus 2 times x minus 5. And there's my answer. If you went one step further and wrote it and multiplied this all out and wrote it in standard form, you would get negative 2x to the third plus 14x squared minus 20x.